What you're looking at is the first image of a black hole, released on 10th April 2019. It shows the supermassive black hole at the center of the galaxy M87. After 4 years, this is only the second picture of a black hole ever at the center of our Milky Way galaxy, known as Sagittarius A. They were taken by the Event Horizon Telescope collaboration. Before talking about why we didn't first photograph the black hole at the center of our own galaxy, in this video we'll talk about how did we take pictures of black holes, because as we know black holes doesn't emit light, and if you wanna see more videos about black holes, don't forget to subscribe. First, let's hear explanation from Brian Fox.
So here, the light, you might say, what is the light in this picture? So it's not from the black hole, because as we've just said, black holes trap light. It's from what's called the accretion disk.
So what the acceleration disk is?
So you're to imagine really material spiraling around in orbit around this very dense object and very violently orbiting, and so it heats up and it emits light.
Well, the first thing to note, they weren't made with visible light. They were made using radio telescopes with a wavelength of 1.3 millimeters. So all the observations were taken by radio telescopes. Actually, observing at shorter wavelengths isn't an option, because the light is blocked either by our atmosphere or by the matter around black hole. So if you wanna see the ring of a black hole, the only way you can do it is by increasing the diameter of the telescope. You would actually need a telescope the diameter of Earth, which is obviously impossible. So instead, radio telescopes located at 8 different locations across Earth all observed the exact same spot in space for a few days. And this is another image that shows how important every single one of them, because if we remove 2 telescopes from the network, which called ALMA and DEPIX, you could immediately see how the image changes. So another famous question is that, where's the accretion disk of the black hole? Our perspective is almost perpendicular to the acceleration disk. We are seeing it, how to say, from above, but if we were looking at different observations, something very weird starts to happen. What you are seeing is actually the acceleration disk in front of and behind black hole. Because the black hole's gravity is so immense, it's causing the light to be bent and distorted around it. When people see the image, most of them are going to ask why the image is so fuzzy. The answer is because it's so tiny. Its size from our perspective is only about 40 microarcseconds. To get a sense of how tiny, take the whole sky and divide it into 100 degrees. The Andromeda galaxy spans about 3 degrees. Then divide 1 degree into 60 arc minutes, and 1 arc minute into 60 arc seconds. Divide an arc second into 100. Into 100 again, and the last time into 100 more. And this is the size of the black hole on the sky. To truly understand the size of the black hole shadow, take a look at this picture. This tiny dot in the center is our Sun, and the orbiting planet around it is Pluto. And this is Voyager 1, the farthest space probe has ever left the solar system. And the giant we are looking at here is the black hole at the center of the galaxy, Messier 87, has a radius 120 times of the distance between the Earth and the Sun, and it has a mass of 6.5 billion of our Sun. It's actually supermassive, but located 53.5 million light years away. At first they planned to image Sagittarius A first, since it's in our own galaxy and 25 light years away, and it has a mass of 4 billion of our Sun. But for its size, Sagittarius A doesn't consume that much matter. It's usually quiet and dark, but the supermassive black hole at the center of M87 is much more active. So it's 1000 times bigger, and it takes 1000 times longer for objects to orbit around it. And that means from Earth its appearance is more consistent. And that's all about the picture of black holes for today. And if you want a video about how did we detect the black holes, let me know in the comment section. Until then, take care of yourself.